Hey guys, this is Aniket and I'm back with a new tutorial series on solid principles. Solid principles are basically an acronym which consists of five main principles. Those are single responsibility, open closed, Liskov substitution principle, interface segregation principle, and dependency inversion principles. So these are the building blocks of a software architecture which renders with maintainability of code. It makes your code flexible and even it makes your code a lot more readable as well. If these principles are not implemented, that might even lead to your code being messy and you might end up being in a situation where it is very troublesome to make any simple change in the code. So these solid principles are applied on object-oriented design. Solid principles even work as a philosophical, methodological building blocks for agile development and other software development methodologies. Let's quickly get to the first principle, which is single responsibility principle. As the name suggests, guys, single responsibility means each software module should perform a single task. May it be a function, may it be a class, it should be subject to change only if there is one change required. If it requires multiple changes, that means you have violated the basic principle of single responsibility. If you want to give a real world analogy, that would be like if there is a method which performs addition of two objects or two integer numbers. This method is expected to only perform the addition and return the result. It is not expected that this method prints down the value for the final result. Let's quickly see an implementation with Swift programming. I have used Swift here. You might use whichever language of your choice. I have taken an example class here as software engineer. Now a software engineer can perform a lot of tasks like coding, testing, or even documentation. So I have primarily jotted down four functionalities related to a software engineer, which is coding, unit testing, sanity test, and writing test cases. If you observe this carefully, these functionalities can be classified into two separate groups, one belonging to the task that a developer does and another belonging to a group where the tasks are being done by a software tester. To achieve single responsibility, we are going to segregate this in two classes. So these two different classes are developer and tester. Now the developer is going to perform tasks related to coding and unit test, while tester is going to perform tasks related to test cases and performing the sanity test. Although you have achieved single responsibility here, but the code demands every time two objects to be created, which is not efficient computationally. It might even lead to lot more resources being used eventually when the final product becomes live. To avoid this computational expense, we are going to achieve this with the help of protocol, or protocols are called as interfaces in Java. Here I have created two protocols. One defines methods related to a developer. So can an engineer be a developer? If yes, then it has to implement these two tasks. Next question is, can an engineer be a tester? If yes, then it has to implement these two functions. We have taken another class which is engineer. Now engineer implements these two protocols, can be a developer and can be a tester. That's how we have segregated the code. We have made the code a lot more efficient, a lot more readable, and we have decoupled the responsibility from a single class which was existing here. Now if I would like to make any change related to the development qualities of an engineer, I can simply go here and implement this. What the heck, guys? We have made the same thing again. If you see here, the software engineer class here consists of these methods. Again we have got similar implementation here. So let's see what we are missing out on. Yeah, so we should be creating local objects for each of these classes, developer and tester. So let's do that. So the implementation would be something like, the engineer class will simply call the methods related to these two respective classes. Let's do the similar thing for tester. Now instead of implementing the methods here, the actual implementation would reside with the developer and tester. So let's call those respective classes, the respective methods for those classes. Similarly here as well. Let's do the same for tester as well. There you go, guys. So we have successfully implemented the first solid principle, that is single responsibility. Now the code that you see has been immensely decoupled, and the changes that you would like to make related to the qualities of developer, or the functions that a developer is going to perform or a tester is going to perform, that are nowhere related to the class engineer. Engineer is only going to call the methods, while the actual implementation resides with developer and tester. There you go, guys. So thanks for watching my video. If you like my video, feel free to like and subscribe. If you have got any further questions, feel free to comment it out here, and yeah, I will see you next time. Thank you.